Hello guys, this is day 18 of our daily push-up challenge while doing some Putnam problems. This problem right here is from Putnam 1942, and you'll be like, oh, 1942, isn't that the World War II? And you'd be right, of course. And in fact, in 1943, 1944, and 1945, there was no Putnam competition at all. And that's presumably because of the ongoing World War II. But anyway, enough about that. We read the problem, but first, let's insert one set of 5 push-ups.
1, 2, 3, 4, 5.
Okay, so the problem reads, let's write our progress here. The problem reads, is the following series convergent or divergent? So you have 1 plus 1 half times 19 over 7 plus 2 factorial over 3 squared, 19 over 7 squared, plus 3 factorial over 4 cubed, 19 over 7 cubed, plus 4 factorial over 5 to the 4th, 19 over 7 to the 4th, and so on. Okay, so let's write first how this series looks like. So any nth term, so the first term 1, let's call it the term n equals 1. So any nth term, if you're seeing in the denominator, they go in the first coefficient, they go 1, 2, 3, 4. So you have something like n in the denominator, and then that is raised to the n minus 1. Okay, and then you have on the numerator the factorials, they are just n minus 1 factorial. Okay, and of course you have the constant coefficient 19 over 7 being raised to the n minus 1 as well. So that's how the nth term looks like basically. Okay,
6, 7, 8, 9, 10.
Okay, so now let's go for the a n plus 1, the next term. Okay, the a n plus 1 term, that is just equal to of course n plus 1 to the n, and in the numerator you have n factorial 19 over 7 to the n. Okay, and I want to get the a n plus 1 term because I want to take the ratio a sub n plus 1 over a sub n, and of course this ratio, we're gonna use the ratio test, because it's a straightforward test. Ratio test is if you take the limit of a n plus 1 over a sub n, you take the limit as n approaches infinity. If it is less than 1, the series is convergent. If it's greater than 1, the series is divergent. If it's equal to 1, then it's indeterminate, and you have to go look for another convergence test. Okay, but it's one of the most straightforward ones, so we're gonna do that. Let's continue first.
11, 12, 13, 14, 15.
Okay, 15. Right, so an plus 1 a sub n. So let's copy first the coefficients involving n to the n, and then you have a over n, and then you take the reciprocal, so you have n to the n minus 1 over n minus 1 factorial, and then you have 19 over 7 n divided by 19 over 7 to the n minus 1, so that will just leave you with 19 over 7. Okay, so this ratio is just equal to, so this is n factorial, I can write that as n minus 1 times n, okay, over n plus 1 to the n, and then you have n to the n minus 1 over n minus 1 factorial, sorry, this is factorial, okay, 19 over 7. So this will cancel, and then you have n times n to the n minus 1 is just n. So you have n over, n times n to the n minus 1 is just n to the n. So you have n to the n plus 1 to the n, 19 over 7. This I can always write as, so I divide both numerator and denominator by 1 over n to the n. So you have 1 over n to the n plus 1 to the n, 19 over 7. And then the 1 over n plus 1 to the n, I put it inside the parenthesis. That should give me 1 over 1 plus 1 over n to the n, correct? 19 over 7. Okay?
16, 17, 18, 19, 20.
20. So now we take the limit. The limit as n approaches infinity of a n plus 1 a n. So that's just 19 over 7, 1 over the limit as n approaches infinity of 1 plus 1 over n to the n. The limit of the denominator should look familiar to you, alright? It's just the number e, okay? That 1 plus 1 over n to the n, if you take n to the infinity, that just give you e, 2.71 and so on, okay? So the whole thing is just equal to 19 over 7 times e. The question is this less than 1 or is this greater than 1? Let's finish the push-up.
21, 22, 23, 24, 25.
Okay? 25. Of course, in order to check, we can pull right here our trusty calculator. If I can. Okay. So we have 19 divided by 7 divided by e. Where's e? Here. Okay. Equals. So that's just equal to 0.9985, which is of course less than 1. Okay. So since we know that it is less than 1, therefore the series is convergent, okay? And so we're done with the test. The ratio test works because the ratio of a n plus 1 over a sub n as n approaches infinity is less than 1. Therefore, the series is convergent. Although it's very near the, you know, the boundary of the ratio test not working at equal to 1. But anyway, yeah, this has been day 18 of our daily push-up challenge while solving a problem from 1942. We only have 7 days left, which is exactly 1 week, and then we're done, okay? But anyway, guys, thanks for watching. See you next time, and bye-bye.